Good afternoon, everyone. So we were discussing fuzzy controller problems. So this was one which I asked you to try. Okay. So I just want to recap it. We'll just draw the rule base for it. We'll just try to write the rule base for this. Okay. And then we'll move on to the next problem. Okay. So what is mentioned is that there are three descriptors for input and output variables. So that is what you have. So how many rules will you have? The problem is on the screen. We are you thinking of all possible combinations. How many rules will we have? Including both the inputs. Yes. How many rules? Come on. There are two inputs. What are the two inputs?
Water temperature and grade of water.
The temperature of water and the grade. Okay. So, and there are three descriptors. So temperature again you can have as cold, normal, hot, right? And grade can be low, medium, high, something like that, right? Similarly, the output, what is expected? The amount of purifier, right? So again, that could be a small amount, medium amount, or large amount, right? So uh, depending on this, so the output also I'll write it here. Output is nothing but, what is the output? The amount, right? So of purifier. So that could be small, temperature will be cold, medium temperature, hot temperature. Okay. And this grade could be low, medium, high grade. Okay. So if you are designing your rule base, you have, you're looking at all combinations, including both inputs. So how many rules will you have?
9.
9. Right? So let us think of the rule base. What will be the rule base? This is the temperature. This is the grade. Okay. Temperature. We'll write the descriptors of temperature here, descriptors of grade here. Okay, now we have to decide the rules. So what is given in the question is clearly indicate that when the temperature is low, the grade is low, then the chemical use is in large amount. Okay. So what will the rules be? If the temperature is low and the grade is low, so definitely it is large amount. So then what you need to do is, see, grade is definitely telling you what is the quality of water, right? Grade of water is telling you what is the quality of water. So uh, it is, there is one indication that is given to you, that when the temperature is low, the chemical required is large. Okay, so that tells you that if grade is kept constant and the temperature increases, then what will happen?
Amount decrease.
Amount will decrease. So that is how you have to form the rule base. Okay, so let us try to form the rule base here. So if the temperature is cold and the grade is low, then it is low. Now if temperature is increasing, okay, grade is constant, it is low only, low quality, low quality of water, right? Low grade of water. So the what about the purifier amount? It could be, you can decrease it, you can make it medium, right? And what about this? Temperature has further increased. It has become hot, temperature of the water. Okay. You can again decrease it. Okay. So again, there's an option here. It could be LM here. This could be MS, right? Next. For now, the grade has improved. Grade is medium and temperature is cold. Then in that case, what will come here? What should happen? The amount, with the amount of the purifier, grade is better, temperature is still low.
M or L.
Yeah. So that amount will reduce now. Amount will reduce. M or L, can have L here. Then what about this? We are going column wise. We are increasing the temperature. Okay, this is dependent on the temperature, keeping grade as constant. Okay, so what will you have here again?
M or S.
M or S. Okay, and then finally
S.
S. Again, now the grade has improved, grade is high quality, temperature is, again you start from cold, temperature is cold. So again this could be M or S. Okay, but since it is high quality, you can keep it as S, because the grade is high quality, right? So you can keep it as S. That will remove that, let it be. So now your quality of water, the grade of water is high quality. Okay, and temperature is now increasing. So as the temperature increases, what should happen actually? The amount of purifier should decrease, right? Should increase, sorry, should increase. But remember that the quality of water is high. Okay, so what will you have here?
Amount will decrease now.
Quality of water is high. This is, temperature has increased. So because of increase of temperature, the amount of purified required is less, and quality is also high. So this could be again M or S. So it depends on what you chose here. Okay, and finally, what will it become? It will become S. Okay. Now we have to decide whatever the slashes are, we'll remove this. Okay. So here, if I say large amount, then you will have, so it could be LMS. You're saying this as LMS. Okay. Then this, what about this column? Again, the same thing you could do, or you can say, since the grade of the water is very low, we will just keep this as M. Sorry, L. Are you getting it? LL. You could keep this as M, it is fine, but just using intuition here. So L, L, and then M. Okay. And then again here L, M, L, after L you will have an M, because since I have chosen this as L, this will be an M. And what about this? You can keep this as M or S. So let me choose it as M. Okay. Similarly, this is LMS and this is, so it is sorted now. Okay, this could be M or S. Again, here also there was a contingent. So here I chose M. So here I can choose M or S. Okay. If I choose M here, sorry, if I choose S here, so the number here will actually increase. Number of S's will increase. Actually, what is suggested that whenever there are three descriptors, then you try to occupy maximum with the medium one. Okay. But there are only three descriptors in the output. You do not have five descriptors like the water washing machine problem. Okay. So somehow you are balancing it out. Okay. Since we had five descriptors in the washing machine problem, what we did was the very extreme ends we uh, uh, just took one each. Okay, from this table, but and then the rest we distributed. But here this is not the case. There are only three descriptors in the output. Okay, so accordingly, so that is why I tell you every time that whenever you're designing a rule base, read the question carefully and use logically. You write the rule base, because you're bound to make mistakes only here. Okay, everything else you'll get it fine, right from designing. I mean, the fuzzification of inputs, outputs, all that is fine. But here you're going to make a mistake. Okay, so carefully read the problem and then solve. Okay, after this, then you have to follow the same steps. So that is fine. Okay, so now we'll move to another problem. Okay, where
Ma'am, just a question. For the high
yes,
grade, when the temperature is low, you have kept it small.
the high
And
grade,
when the temperature is cold, the amount is small. And if the temperature is increasing, the amount
keep it
should
as
decrease.
medium. Keep it
Uh,
as medium.
yes,
Now it is fine.
yes.
Okay. So this is about this problem. Let me switch on to another problem. I'll share my screen again. Okay. So now in this particular problem this is a typical problem which is used in most of the libraries which you will find. So whatever fuzzy libraries which are there in Python or in MATLAB, you will find this as a standard problem. It is called as a tipping problem. Okay. This is called as a tipping problem. Now this tipping problem is basically a scenario is given to you where you have to, your controller or the fuzzy knowledge base system is supposed to find the tip that is expected given these two parameters. So these are the input parameters, that is the service of the restaurant. So it's talking about a restaurant. Okay, and the service and the quality of food, the quality of service and the quality of food. Okay, so there's a rating for this service and food quality between 0 and 10 for a restaurant. You're assuming that. And based on this rating, what should be the tip? That is the problem. The problem is you have to compute the tip based on the service and food quality. Now, you have certain assumptions here, like the tip. Now, if you go from country to country, and from the type of restaurants to different, I mean, if it varies, like if it's a 5-star restaurant or it's a local restaurant, it will vary. So certain assumptions are followed. Even from country to country, it will be different. But that assumption, either if it is not mentioned, you are assuming it, or it is mentioned. So that is what is mentioned here. It is mentioned here currently that the tip is between 0 to 25% of the bill. So this range is given to you directly here. Okay. Now, what else you have to do here is, if you look at the kind of rules which are used here. So whatever rules we have written so far, we have always used the AND operator to combine the two fuzzy sets, or the fuzzy descriptors. So the service is poor, food is rancid. Okay, we use AND everywhere, and we found and we included both the inputs. We included both the inputs every time. It was not that you had a single input anymore. So for this particular problem, assume that these are the rules. Okay, so now you understand that in the real world scenario you will not have so many rules. Like if there are 7 descriptors everywhere, so you will not have so many rules, 49 rules or something like that. But usually the rule base is decided in consensus with a domain expert. Okay, so since we are not the domain experts, we are assuming those many rules, and it's like we are just doing it at a lower, I mean, level. We are not doing at the real world scenario level. Okay. So here what you have is, you will have in a real world scenario, many a times you will have a reduced set of rules that will depend on the expertise of the domain expert. So he will guide you as a designer for a system. You will also include a domain expert to give you this knowledge, so that you don't have so many rules which are unnecessary, because that depends a lot on what kind of inputs are there in the system, usually which are found. Okay, now just for assumption purpose, there are 3 rules which are given to you. Okay, these rules you have to use as part of your rule base, rather than having 9 rules or whatever. You will have these 3 rules which are given, and you'll notice that here in 1 2 rules there is the or operator. So you're combining the inputs using or. Okay, either of these two is true, then the tip is either cheap or generous. So that is what is mentioned. Okay, and there is one rule which is having only a single input, that is service is mentioned here. Okay, and that will decide whether the tip is average or not. This is given to you. You have to use everything else, you have to design in the same way. Only thing is, you have to given for these given inputs, service is 3 and food quality is 1. You have to infer using mean of max and centroid method. Okay, so mean of max and centroid method you have to use. So one by one. So first we'll find the tip using mean of max method for service equal to 3 and food quality equal to 1. Second way, you will find the tip using centroid method. Okay, so mean of max is pretty straightforward. So the steps will remain same. So identification of input output, everything is given, almost everything is given to you. Now from these terms which are mentioned, that is services, poor, good, whatever, excellent. Okay, so we will, based on these terms, we will write the linguistic terms or the descriptors which are there for the inputs, and let us straight away decide what the functions will be. So we'll assume the ranges. See, it is mentioned that the rating is between 0 to 10, and the tip is between 0 to 25%. So we have the universe values as well. So let us start solving the problem. Okay. So what is the first step is identification of inputs. So we'll just go to step 1 is given to you. Okay, we'll go to step 2. Step 1, just write it quickly. that is service, food. These are the inputs, right? And the output is tip. Okay. Service is poor, good, excellent. Okay. And food quality, what is mentioned is rancid and delicious. So rancid, say good, and delicious, or you can use some other word. Okay. Delicious. The range is 0 to 10. Range is 0 to 10. And for tip, you have either cheap, average, or generous, right? So this is 0 to 25%. This is given to you, and on the basis of this, we can draw, or we can have the step 2. What is step 2? Step 2 is basically fuzzification. So fuzzification, you will have the graphs with you. Okay. So you can choose some other ranges. I'm choosing some ranges. If you follow this, we'll get the same answer. Okay. So for the service, you have poor, good, and excellent service. Okay. So this is poor, what I have taken here while solving is this is poor. This is up to you, huh? Remember, this is up to you. But if you're solving it along with me, then we should get the same answer. So because of that, it's better you take this. So this is for service. Service is X. This is mu of X. Similarly, you have the food quality, the next input. Service quality is done. This is food quality. Again, you have, I'll take the same things, same values. Okay. It will be similar only. Okay. Only thing is this is rancid, good, and delicious. This is food. And again, for the tip, what about the tip? The tip will have again up till 25%. Okay. So the tip is cheap, is average, or generous. Okay. So these are our graphs. Next step is rule base. Rule base is given to you in this case. So rule base is already given, so we'll skip it. Okay. Step 3 is rule base, which is given. 3 rules are there in the rule base. Okay. So we go to step 4. Step 4 is rule evaluation. Directly we will evaluate the rule for the given inputs. What are the inputs given to us? The inputs given to us is service is 3 and food quality is 1. So for these inputs, we have to find out which rules are going to fire. Out of these 3 rules, which of the rules are going to fire? Okay. And then we have to compute the tip using these two methods, that is mean of max and the centroid method. Okay. If you're using mean of max, we know how to do it. So only thing is the type of rules that are there, they are using OR operator here. So what should be the difference? I have told about this earlier. What should be the difference?
We'll take the maximum.
Instead of the min, you use the max operation. Okay. So if you see the inputs that are given here, service and food quality, you check in which rules it is mapping first of all. Service is 3. So you need to look at the membership functions, I mean the graphs that you've drawn, right? Service is 3. Look at the service plot, you will see that 3 lies in which range, right? So that in the if part for service, if there is a rule with service is poor and service is good, then you have to take that rule. Correct? That is the meaning of this, right? The value of service is 3, so it is overlapping in these two. Okay, and the rules, you have to check in the rules, because now we don't have that complete rule base of 9 rules, so all combinations with that. But this is our rule base, which is directly given to us. So from these rules, which are the rules? Out of these rules, which are the rules which will map to that service value 3? Can you tell me? Service value 3 was there for rule 1. It is service is poor. It is coming under poor and it is coming under good as well. Yes or no? So rule number, so if I just number these rules as 1, 2, and 3, there are 3 rules, right? So rule number 1 and 2, they are mapping to service, poor and good. What about food quality? Food quality is 1. So food quality 1, where is that coming? That is coming under the rancid and the good graph, right? Food quality, rancid and good. But if you look here, there is no rule for food quality good. Okay, so there is only one rule, and that is this one. So this rule is mapping to food is rancid. Okay, so these are the 2 rules that we need to consider while computing the output. These are the 2 rules that we need to consider. Are you getting it? Yes. So service is 3 and food is 1. Food quality is food is 1. So service is mapping to, so what do you need to do? You need to substitute this in the equation of poor and good quality of service. Poor and good quality of service, right? So these 2 equations, this equation and this equation, right? These 2 equations. So what will you do? Poor of x. What is the equation? This equation. What is the equation of this line? It's a decreasing line. 5 minus x divided by 5. Yes. And the second one is good. What is the equation of this line? second line. It is x divided by 5, right? So now if we have, what we need to do is this service value of 3, we need to substitute here in this and this, right? So you will say 4 of 3, what is it equal to? 5 minus 3 by 5, right? That is 2 by 5. What is the value? What is it? 0.4? Yes? And what about this? This is 0.6, right? Is this clear?
Yes.
Okay. Now that we have this, now we will look at food. What about food? Food is having which rule? Only one rule, the first one. And that is rancid. Food is rancid. So we will not consider food as good. We will consider food as rancid. Because we do not have a rule which is having food as good. Okay. So for this particular function, rancid of y will be considered. And what is that equation? The same equation as service, because we have taken the same equations of for service and food. So that is 5 minus y divided by 5, right? So rancid of the value we will substitute as 1, whatever is given here, and that is nothing but 5 minus 1 by 5. That is nothing but 0.8. Okay. Now these values you are getting 0.4, 0.6, 0.8. How do you combine? Okay. We will have to look at the rules. We will combine on the basis of rules. We look at the antecedent part of the rules, right? So there are two rules. First rule that is being fired is this particular rule, right? So if the service is poor or the food is rancid, then the tip is cheap. Okay? So that means we just look at the if part of the rule. So the if part is this: service is poor or food is rancid. That means what? You have to look at the membership of service, you have to look at the membership of food, and then you have to apply the OR operation, right? That is a max operation. So for this particular rule, what you need to do is rule 1 is fired. Okay. And what is the strength of rule 1? Strength of rule 1 is nothing but max of which two? Service is poor or food is rancid.
0.4, 0.8.
I'm just writing for reference. So 0.4 and 0.8. That is nothing but 0.8. Okay. What about strength of rule 2? There is only a single fact in the antecedent. It's only a single fact in the antecedent. The service is good. Okay. You don't need to combine. And that value, the membership value, the strength of that rule will be depending on the strength of whatever service is getting there. So what is that? That is directly given. Good. Service is good, right? That is 0.6. Okay. So So these two rules are firing with strength 0.8 and 0.6 respectively. Now what you need to do? What is the next step?
Defussification.
Next step is defussification. Very good. So there are two methods that we have to use. First method we are aware of very well, versed with it. Okay. So mean of max. First of all, what do you need to do? So defussification, first method we are using is mean of max. Okay. What are you going to do for mean of max? N, this is N. You find out of these rules which were firing, you found out which was the rule which was firing the max, which was having the maximum strength. That is what you did, na? You had 4 values here in that rule base. That means those were rules. And out of those, you picked up the value which was the highest, right? So max value is max of 0.8 and 0.6. This is rule 1. This is rule 2. Out of these two rules, this is firing. So this, I mean, highest. This is the highest. So you take it as 0.8. And then what do you do with this value? You look at the rule, na? You look at the rule. Rule 1 is firing. You say rule 1 is firing. What is there in the consequent part of it? Of rule 1. We'll go back to the rules. You look at the then part of it. The tip is cheap. Tip is cheap. That means you need to look at the tip now. The tip is cheap. Only this particular function, the tip is cheap, is the one you need to consider. Okay. So tip is cheap. So that means this particular function, you're going to evaluate to whatever is the rule strength, right? The rule strength, that means it is cutting this off, right? So this is having something, this is having, you remember that graph which I had drawn for one of the examples? It was poor to what extent? Rancid to what extent? And then you were combining. You're plotting it on the output graph. So now the plot here will be, this is the first rule that is firing. First rule was poor, service is poor to what extent? Service is poor to what extent? It is 0.4, right? And somewhere here, 3 will be somewhere here, right? This extent. So food is rancid to what extent? Its food value was 1, 0.8, right? And then we, what did we do? We were plotting it here. Okay, out of these, which ones we will take? That depends on what is a combination operator, either and or. Here it is and, sorry, here it is or, right? So since it is or, what do? You take the higher value, you cut this off. You are clipping the output. This is the output. You're clipping. You're clipping the output. Clip it, right? So this is what you're getting. Okay. So you have to put the value 0.8, whatever. This is 0.8, right? This 0.8 you have to put. This is 0.8. This is 0.4. Right? This 0.8 you have to put in this equation. And you will get the defussified value. Okay. So 0.8, that equation, the equation of that line, decreasing slope. What is the equation of that line? It is
15 minus x by 15.
15 minus x by 15. So 15 minus x, whatever, z, value z, by 15 is 0.8. So what is the value of z?
3.
Is 3. So z, the tip is 3% by mean of max. Now how do you do it for centroid method? How do you do it for centroid method? You need to find the centroid of this area. You need to find the centroid of this area. What is the centroid of this area? Should it be this area or it should be, see, this is mean of max, not this area. It is something else. This mean of max, so we considered this. But there were two rules which were there, right? There were two rules. This was one rule, this was the other rule. So there's one rule which is still remaining. Since it was mean of max, we eliminated this rule. Okay, max ही consider करना है mean of max. But for centroid, you have to consider and all the rules which are mapping and then take the overall output. You remember aggregation of all the outputs. Okay. So what do you do for that? Aggregation you need to complete of all the output. This is the first one. And apart from this, there'll be some part of this 0.6, ये जो 0.6 है, this one. When the service quality is good, then the tip is average. Then the tip is average. Okay. So that service quality good, which was this particular point where we got. Okay. So whatever we got, service quality good. Here, wherever it is cutting this 0.6, suppose this is 0.6, right? Are you getting it? This was 3. 3 was cutting poor at 0.4. It was cutting good at 0.6, right? So this good will be directly projected. Let me use another color so that you get that this is another rule. This good will be directly projected to what? To the antecedent, to the consequent part of the rule. And what is the consequent part of the rule? The tip is average. So it should cut that off. The tip is average. Okay. This is clip. This is the clip. Average function is a triangular function. Okay. So you are getting what is the area that you are going to consider, whose area centroid you need to find. It will be this, the union of this area and this area, this clipped area. The entire area is, are you getting this blue one and this? So the area, let me shade it out for you so that you understand. It is this entire area. Are you getting it? Yes or no? This is the area under consideration. This is the overall output. And for this overall output, now you have to apply the centroid. Okay, whatever, whenever you apply, you will get centroid method. You will have to look at this combined area and then find the centroid of it. You remember the equation. You can use any other way also. I mean, you have to find this point and all that, and then you have to equate it, right? Or you can divide it into logical subdivisions, find the area, and then find the centroid of each, and then take the average. That could also be done. Okay, I have shown the integration method to you. So you follow that and find the center. Everyone has understood how this output has come out to be? How did we combine the two rules?
Yes, ma'am.
So this is the combined area. You find the centroid for this and let me know. Will you tell the answer next time?
Yes, ma'am.
So find the centroid and let me know, because that will take a while to compute. Okay. So I'll stop here. So this is how you compute. So any problem scenario is given to you, like this tipping problem is a very classical problem which is discussed, and it is available in the libraries. Maybe in the lab session, I will also just give you a demo of this. Okay, it's present in the Python fuzzy library also. So I'll give you a demo of this. And any such problem which is given to you, if the rules are stated explicitly and you are asked to compute using any other method of defuzzification rather than mean of max, you should be able to do it. Okay. As practice, I will put up some problems for the same so that you get some practice on those kind of problems. Okay. So that's all for today.